In another video, we talked about the impacts that climate change has had to temperature and to the organisms, including humans living on Earth, and the impacts to temperature and weather and how it impacts us. This video is going to talk about big ice. So there's a lot of ice on Earth. We've got glaciers, we've got Antarctica, we have the Arctic. So we're going to talk about the impacts that we're seeing to these icy regions of the Earth. And then we're also going to explore only a little bit, but explore a little bit about what we think may happen in the future and what we might expect to see. So when thinking about ice, we're going to first start with glaciers. So glaciers are thick pieces of ice. When I say thick, I mean, it depends on the region, but some glaciers, you're talking about hundreds, if not thousands of feet thick. Glaciers are actually left over from our last ice age. So our last ice age was around 10,000 years ago. If you've seen the animated movie Ice Age, it's based on that most recent ice age. Earth has actually had lots of ice ages. We kind of ebb and flow. So the most recent ice age, about 10,000 years ago, the northern hemisphere was essentially covered in an ice sheet. As it started warming and we kind of were coming out of our ice age, that ice sheet melted. But in some areas of Earth where it's still quite cold, like closer to the Arctic, that ice remained. And that's what glaciers are. So glaciers are just a remnant of that ice cap from the last ice age. So ice that's been around for 10,000 years. This top picture is from 1928. This is taken from Glacier National Park, which is in the northern part of Montana in the United States. So, very, very cold region. This ice that you're seeing in this picture has been there for over 10,000 years. So this is 1928. We jump into the future about 80 years and look, it's nearly all gone. I shouldn't laugh. This was actually really sad and really bad. But there's nothing left here, right? Like there's maybe a little bit of ice in the background, but this was ice that was there for 10,000 years. So huge impact. Huge, not so good impact. Now looking at it, you might be like, well, we have land now. We have a nice freshwater body. This might be more habitat, and I don't disagree with you. The habitat in the bottom picture is a lot more amenable to species diversity than the ice sheet above. However, that water had to go somewhere, and we're going to talk about that in a little bit. Some of the water did stay behind, but a lot of it had to go elsewhere. The other thing, too, is it's just a very stark realization that, yes, something is happening to our climate. Ice that's been there for 10,000 years is no longer there. So if anything, if you're like, well, that habitat's nice, I actually don't care if the glaciers melt, fine. But at least recognize the fact that they are melting. Something that hasn't been melting now is, and it is quickly. Not only did it melt, but it did it in 80 years. And it's been there for 10,000 years. So it's kind of saying something. Now this is looking at Glacier National Park, but this is happening worldwide. Happening a lot in Russia as well. That has a lot of glaciers. It's actually kind of funny in a really kind of sad kind of way. If you go to the Glacier National Park website, they pretty much are saying like, hey, if you want to see glaciers, come sooner than later. They say it a little bit more professionally than that, but they recognizing that the namesake of this national park is going away. Soon, they'll just call it National Park. They're just going to drop the glacier. All right, so that's glaciers. So that's one piece of big ice. Let's talk about the Arctic. So the Arctic is north. So northern hemisphere is our northern ice cap. Now, before we talk about some of these graphs and some of the pictures on the next screen, something to keep in mind is that the Arctic is like an iceberg. There's no land underneath it. So with glaciers, there is land underneath it. We kind of saw that in that picture. But the Arctic, there's no land. If it were to 100% melt, it would just be water. There's no land mass under it. This is going to matter in a little bit. So in the Arctic, it's crazy melting. And here's what I mean by crazy melting. So let's talk about the not so crazy part. So in the winter time, so looking at about March in the Arctic, this is looking at, March for the past, 50 years. or really past 40 years. 1980, we have an extent of 16 million square kilometers. 2020, about 14 and a half. Okay, so it is declining, but it's not that drastic. It's getting smaller every year. Every March, it's getting less and less, but not a big deal. But let's take a look at the end of summer. Let's look at September, same time period. Now, naturally, the Arctic shrinks in the summer. So the Arctic does ebb and flow with the size. It's largest in the wintertime, it's smallest in the summer. That has always been. So that is not a climate change thing. But take a look at how much it's melting in the summer. So historically, about 40 years ago, we're looking at about 8 million square kilometers. 2020, we're at 4. Half the size. It's already small as it is in the summertime. But now, in 40 years, we have shrunk the Arctic in half. That's huge. That's a big deal. Let's talk a little bit about why it's been melting so much. So, think about wherever you live, if you get snow. If you're living here in Maryland, you do. And you know they say that if you're going to be outside for a long time, you actually should put sunblock on. And that's because the ice almost acts as a mirror. Like the sun hits it and it scatters. And it's super bright in sunny areas. Snowboarders and skiers routinely get sunburned because that light bouncing off the ice is so bright. So now think about the Arctic. Huge slab of ice. The sunlight comes in, it hits that ice, it goes back into outer space. But here's the thing. As it's getting warmer, the Arctic is melting a little bit. And so sunlight comes in, and maybe it's not hitting ice anymore, it's just hitting the water. The darker water. The water that absorbs sunlight. The water that absorbs that sunlight and converts it into heat. Well, now what's happening is our oceans around the Arctic are getting warmer. Not getting warm, getting warmer. Which is helping melt the ice. And as it melts the ice, there's more water around, which means as sunlight comes in, it's hitting more water, warming it more, and melting more ice. And we're getting this constant feedback loop. In the summertime, it's even worse because temperatures are already warmer as it is. The Arctic is already smaller as it is. And so this feedback loop keeps feeding and feeding into itself until eventually we don't have the Arctic anymore. Depending on how old you are when watching this video, that might happen in your lifetime. I totally foresee us having a summer where there is no Arctic. It's coming. In 40 years, we've declined it in half by 4 million kilometers. I think, personally, it's going to take even less than that to do the remaining 4. I want to be wrong, but science is not showing that I will be. But we'll see. Maybe we make drastic changes and we don't have that. And that's what all we can hope for. I want to show you, the next slide is still about the Arctic. I want to show you 2 different pictures though. So here's March. Again, this is the cold time of the year. This is when the Arctic is the largest. This yellow line is representing where the Arctic typically is. So the average width or average, diameter or extent of the Arctic. And then the white is showing this past March. Okay, here's what it actually was. And you can see, yes, it is declining, but not that much. It's not drastic. Well, here's September. Looking at the same thing. The yellow line is showing, okay, this is typically where it is. And it's smaller than where it typically is in winter. We kind of expect that. But take a look at where it's looking at in September 2020. Look at how much smaller it is from the average, or from the median, I should say. Look how much thinner it is. You can see blue through it. This is meaning that the ice isn't as thick. Or you can just say in general, it's thinner ice. This should make sense because the water is all around it. It's on the left, it's on the right, it's in the front, and it's in the back, it's underneath. So it's melting this ice and it's melting it rapidly. So these are no bueno. No bueno. And it's only getting worse, unfortunately. Now there's one more piece of ice we haven't talked about yet, and that's Antarctica. So Antarctica is in the southern hemisphere. This is our southern ice cap. It does differ from the Arctic in the sense that there is land underneath of it. If Antarctica were to melt, it would be on land. Yeah, so it's different because that means water and water temperature doesn't impact Antarctica as much as it does the Arctic. And here's what's happening in Antarctica. So this line, this gray line, is showing the general trend is increasing, albeit it looks like it's increased by like 1% over the past 40 years. But notice the variability in Antarctica. So some years it's grown 10%. So a positive number means it's growing that much. Other years it's declined, -12%. So it's gotten smaller by 12%. And it's so variable nearly every year. Sometimes it's growing, sometimes it's shrinking. Sometimes it grows a lot, sometimes it shrinks a lot. Antarctica is just doing its own thing. And honestly, scientists don't quite understand why. We understand the Arctic pretty well just because it's surrounded by water. We just understand it a lot more. We can understand why it's melting. With Antarctica, we don't really understand why it melts some years, why it grows other years. But we do know that it's been fairly constant in the sense that there's not rapid growth and a lot of it, and there's not a lot of decline. It's more or less staying kind of stable. But don't take my word for it. There's going to be a video that you guys are going to watch from a NASA scientist, or kind of a group of scientists, that this is exactly what they study. They study sea ice extent in Antarctica and in the Arctic. Now, this video is a couple years old. It's actually during a year where Antarctica was growing quite a bit. So when they're like, oh, and Antarctica is growing, they're just referring to one of these peaks in the past. So go ahead, pause here, click on the link that's popping up, and then come on back. So I would say hopefully you learned something from that, but in that video they also tell you they don't quite understand what's happening. But I think the imagery that they use, kind of showing you this actual ice extent, is pretty powerful. And I don't know, I just find it cool. People at NASA are pretty cool.